Hi everybody, welcome to this series lectures about the prepare for linear algebra examination. Well, some of you may have taken my course already about the calculus. Yes, if you're nervous, you're afraid, or you have the great determination to understand and learn linear algebra, or you're happy with my education style, and you're happy that you learn a lot from the sister lecture series about the calculus, you're more than welcome to take this linear algebra. Okay, so this one is made for the students who is totally new to the linear algebra, like you're still in your first year in your college, or you are a very good high school students who want to take in the AP examination, to reduce your cost or time cost in your college study. You're welcome. Or for the people who have already taken this course, the people who take this course 10 years ago, but now your career asks you to apply some of the linear algebra into your work. So you don't know where to start. It seems like you don't want to jump into the heavy book, or you totally lost your textbook already. So you're welcome to. Or for some people who are having its examination in a few months, please join us and practice. Alright, the next point is about the education style from me. So the course here is going to be very systematic, but also going to be very specific, because we're going to talk about all the key points, which is very useful in calculus systematically, but we're going to give you the examples all the time and a very detailed explanation. And also, this is a very serious course, but I will trying to inspire you, to encourage you to take it and be successful. And also, I'm gonna use my hand, use my pen to give you the explanations, and hopefully you can do the same thing too. Because there's no way for a person to learn the math well, just by reading the books or just watching some videos. You will have to write it down, just like what I do here, to really master the math. Alright, so now let's continue our conversation about how to be successful here. So you have to take notes, of course. You have to practice on a piece of paper, and you have to think about every concept and every deduction that I make here. You have to mimic and write down by yourself too. And always review your notes if you have any question when you are in a new sections, but you have a confusion about the old knowledges. You always have to review. Yes, our goal is to help you understand and grasp, really know how to apply the linear algebra knowledge into your everyday study or work. And hopefully through this course, you can form the fundamental mathematics thinking pattern. Like when you come across knowledge, which is complex, it seems, do you know how to make it simpler? Do you know which model you can take advantage of to the actual problem? Yeah, that's what we call the mathematics thinking pattern, or the philosophy of mathematics, which can help you a lot to learn different branches of mathematics, and also can help you to resolve different kinds of problems in the reality. Alright, so in this whole series of lectures, we're going to talk about the following knowledge points about linear algebra. We're gonna start from the determinant matrix, which is very basic knowledges for linear algebra. And then we're gonna come to vector equation set. Well, this is the core skill you have to master. And then we're gonna get into the application situations about linear algebra. So we're gonna look at the eigenvalues and also the quadratic form. So why don't we start now with the determinant. Okay, so in this chapter, we're gonna look at those key points. The first one is the definition about the determinants. The second one is about the properties of determinant. And then we're gonna look at some real calculation problems related to it. You will meet the concrete ones, which means I will give you several examples like, can you calculate, determinant of this one? 5, 6, 4, 3. Yeah, or more complex ones. 2, 1, 1, 4, 7. Yeah. Okay, or the abstract ones, which means there is no such number expression. For example, I would say, the determinant A times determinant B divided by determinant C. How we do this? Okay, and then we're gonna look at its applications in the real problems. All right. So we can have a wondering, who made this? Determinant as the first part of linear algebra, or to say the higher or advanced algebra. It seems to be very complex. Or to say that the algebra for most people looks very abstract, very difficult, because compared to geometry, which is also another branch of mathematics, it has shapes, right, for you to understand it more intuitively. But abstract is made of the symbols, ideas, theorems, yes. So who made this? Well, these guys. Well, we have the argument about who really first proposed the determinants. However, usually people mentioned this German mathematician, which is very famous in your calculus book too. Okay, so the second one is the Japanese one, which maybe you're not familiar with, called Saki Takakatsu. Yes, but we don't care about who made it. In today's lecture, we're gonna focus on Lexis, the French mathematician, proposed the geometry definition of determinants. Alright, let's get into it. Alright, so let's look at how we can find out the reason why the determinant is defined like this. Like what? Like this. For example, we have a small determinant like this one. So if you have ever taken this class before, you know it should be goes this way. If you haven't, you can remember this. We're very confused about this. Why? Who made this? Well, that's why we're going to talk about the definition given by Lexis in a geometry way. So we take, the first one, row as a vector, like this. A11, A12, second one like this one, right? So it's A21 and A22. That's easy. Well, let's do some other easy things by extending the lengths each side. So we're gonna form a parallelogram like this. But this one is L, this one is M, and this is our alpha, this is our beta, right? So now can you calculate the area of this parallelogram? If you don't, let's review some high school knowledge. So this small parallelogram with A and B as the lengths of each side and with alpha as the angle between them. So this time, to calculate the area of this one, you have to find out the height first. The height is easy. It's given by A times sine alpha, correct? And then you have to let the bottom B times height, which will give us as AB sine alpha finally. So this time, we can calculate the area of this parallelogram in a similar way. So we have this one as L times N times sine beta minus alpha, because the angle between the L and N is actually beta minus alpha. Okay, and this time we can further expand it as sine beta cosine alpha minus cosine beta and then sine alpha. Okay, if you don't know how you got this, you can review the geometry textbook, maybe in your college or high school class. Okay, so let's further expand it. So this one, we're gonna put L and M into this brackets, and I'm gonna have L times cosine alpha, because L is about this alpha, right? So L times cosine alpha times N times sine alpha, and minus L times sine alpha times N times cosine beta. Alright, so here we're gonna focus on each triangle, like this one, or this one. Well, to talk about further about how we can change this one too. Alright, continue. So we extract those triangles here and put it into this slide. So you can see that for this triangle with a side as L, right? Now we have alpha here. So it means alpha times cosine L times cosine alpha give us A11, because A11 is actually the projection on the x-axis. Okay, similarly, so we have L times sine alpha equals to A12. This one, right? It's actually the y's value, because it is the projection onto the y-axis. So similarly, we can have M times cosine beta give us A21, and M times sine beta give us A22. So that's why we can transfer the final formula we have in the last slide as L times cosine alpha blah 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 equals to A11 times A22 minus A12 times A21. Alright, so that's what we have for today's lecture. So if you are interested in the linear algebra and you find out, well, this type of education meets your style, you're more than welcome to continue to join in the next lecture. Okay, so see you next time.